Right. Good evening, everyone. I hope you are enjoying staying at home as much as I am. Well, life must go on, and we still have to go on with our chapters, right? So let's get ready for chapter 4, right? So today we're going to talk about data preparation part 1, right? So let's take a look at data. So what we will be covering the data lifecycle. Okay, we will be looking at the 8 steps. We'll be looking at also at the data source, the various data source that uh, we can retrieve our data, and we'll be basically looking at data extract, transform, and loading. Right, so let's check that out, right? So data lifecycle, right? So these are the 8 steps. I think it looks like more than 8 steps, but 1, 2, 3, 4, 5, 6, 7, 8. So yeah, right, it's 8 steps. So these are the 8 step plan, collect. Oh, sorry, that's my eldest daughter. Just happened to pass by. Okay, so right, where was I? Oh, I was looking at this data life cycle. So it started off with planning, right? So the 8 steps. So we need to know with start off with planning. We're going to plan what data that we need to collect. We need first, or we want first, right? We need to plan how we're going to control the data. Once you got the data, how you're going to do with the data, and where you're going to start from, and how you're going to handle some of this data, and where are you getting this data from, right? Are you getting the data from the internet, or getting from the user themselves, or are you going to get the data from the various departments like sales, marketing, and so on, right? So that is on the planning part. Then next, you need to collect the data. How are you going to acquire the data from the organizations, right? So it comes from the organization, or it comes from it could also come from some of the IoT devices, right? Internet of Things, the sensors, right? Or any other equipments which you have deployed in the field, right? And they actually been feeding data to you, right? So you need to know how to collect this data, right? And then uh, organize them into a spreadsheet or database, right? So example, if you are in the healthcare industry, so some of these data could be coming from the heartbeat equipment, uh, blood pressure monitoring machines, right? And so you need to understand how you're going to collect them wirelessly or through any line feed or fixed line that's going to feed you with all this data, and how you're going to download this data as well. Okay, so next we move on to acquire, no, assure, right? So when you collect this data, what is the kind of format, okay, that you need to collect, right? Are you going to collect them in certain standard or certain unit, like whether it's going to collect in centimeter, kilometer, gram, okay, the different units, or whether you're going to if you have a temperature sensor to monitor the people coming attending the class, for example, are you going to take the temperature in the form of Celsius or Fahrenheit, right? So you need to agree upon certain standards, okay, that you want. Okay, so that is to ensure that the data you collect is uniform and is of uh, the same quality as well, lah, right? Not that some collect in grams, some collect in kilogram. Then you might have a problem, right? So whether the data coming in, is it 100 gram or 100 kilogram? So you got to standardize, right? So you got to find a way to standardize that. So you need to ensure that data are right, okay? Or whether you want to collect the data in 1 decimal point or 2 decimal points, okay? Right. So then we move on to preserve, right? Preserve. So you also need to, once you collect the data, you have the proper data, you need to find a way to store them, preserve them, right? And you also need to have metadata, right, to describe what the data, right? That's what the metadata you must collect. Whether 100 is that 100 degrees Celsius, so it's a temperature, right? So you got to let people know the temperature of the machine, temperature of the certain part of the machines. You got to identify. You don't just say 100 degrees Celsius, but what is that temperature about, right? Is it the car, the the engines, which part of the engine, etc. So that's where the mega data has to come in. So you need to tag it with the right data. Sorry, right? So once you find a way to protect the data, right, preserve the data, you also must find a way to expose this data that you collected. Even the metadata, you must make it such that it's properly indexed and that people know how to retrieve, and you also must make the data discoverable so that people can make use of the data, right? So, for example, if you have sensors or traffic video cameras to capture the traffic conditions at the causeway point, right? But if such data is not made available to anyone or any application, then the data itself become no use, right? If one company, if you can, if any company can make use of this data and use this traffic data and then develop a mobile app and alert people that there's a jam in the causeway, then that's where it makes the data collections more valuable, and people can basically use your data. So that's why you need to expose, your data, make it available for people to keep having those real-time data, right? So that's also the beauty of having those and data analytics. That's why you can see that government at one time they try to make their government data available to even like system integration or integrator or software house, so that they can use the data, right, and then create some uh, usable app, for people to use it, right? So government don't put sensors everywhere, smart sensors, IoT devices anywhere, right? uh, so if they can make it available, expose it as a web services, so people can actually consume the web services, call the web services, call the interface, and then get all the real-time information that will then people might be able to create some added value to the data. They can even help you to analyze the data, right? So then we move on to integrations, right? How you're going to integrate the data. The data could be coming from everywhere, right? From all different sources. But how do you going to integrate this data and mesh them up, right? And then do a proper analysis transformation into some standard format, right, to be used, right? So data, you don't just collect it from one table. You could be collecting from a number of table or database, right? Or you might be collecting from various equipments also, right? So before you can do a proper analysis, right? So that's where we're going to talk about analysis, right? So when you want to do analysis, you really need a lot of data, right? And you need to extract meaningful data. So that's very important for integration to do a proper job in integrating this data together, so that people can actually can see the data better and be able to extract some meaningful answer, right, to some of the research questions, right? So like just now I mentioned, we are looking at a lot of data and from different source, different tables, and you might need to really merge some of this data into one table in order for you to basically do a proper analysis, right? So the last part in data life cycle, right? The last part in data life cycle is basically to archive, right? So sometimes data we need to back up, okay? Uh, you need to find a way to archive it, right? So data collected after 5 years, 10 years, you need to find a place to store them for historical purpose and for later on retrieval, right? You might not need those data now, but you will be needing them later on, right? So you need to store some of the past data in some data warehouse, for example. So you must find a way to be able to do a regular archive. Okay, like every year you do a proper archive, or every 6 months you do a proper archive, and then again when you archive, you make your database free up some of your existing database, right? For some of your more real time, more operational or live data to come in, right? So you need to, that's where the archiving is also very important, right? So that is the whole life cycle, right? Starting from planning how to get the data, what data to get, how to collect, and then finally you go through all these stages, and then finally you try to store them, okay? Store them and then archive them properly. So so there are So there are some guidelines here that we look at when we collect data. What is required? So that's where we talk about. You need to know your business objective. You need to know your requirement. What exactly is the data that you collected? Is it meeting, or is it going to help you in meeting your business uh, objective? Okay, so you need to find out uh, the actual data that is important, right? And even then, you also need to look at the data, who can use the data, who can see the data, right? So that's where you come about the rules to use this data, right? Some data are sensitive, such as what? Your personal data. That's why you have the Personal Data Protection Act. Right? Singapore put that, and you're not supposed to give, even though you retrieve some of this NRIC number, but you must ensure that some of these data are well kept and only be known to a small group of people on the need to know basis, right? You don't just expose some of this sensitive data, like even the medical health, what is your blood group, right, to anybody who want to do data analytics and then use it, right? So you got to think through who are the people who really need some of this data. So that's the rules part. Now, what are the rules? Right, so there are plenty of sensitive data, even like salary. Not. It's very personal, right? Nobody want to tell people how much you earn, right? Especially your peers, right? Otherwise, it lead to a lot of conflicts. So, like I say, so some of this data can only be made available to certain group. Like for example, salary. Obviously, only the HR will know lah, right? But maybe your colleagues, they shouldn't know. And then we also have to define, once you got this data that you collected, who is going to be the one who own this data, okay, or own this table, own this record, and how are they going to maintain this record or update the record? So you got to define the data owner, right? So once you identify the data owner, understand what are the rules, who can access, who can read, who can update, who can delete. Then you also have to find a way how you're going to store this data. Are you going to store them in the Microsoft Access, or are you going to store them in the Microsoft Excel, or a more better database like relational database, whether it's going to be in MySQL or my Oracle as an example, right? So or where are you going to store this data? Are you going to, if you are an MNC company, are you going to store it in the HQ, or are you going to store it at the various branches as well? You're going to decentralize your data storage, right? For redundancy purposes, etc. So these are some important guidelines in data management, right? And how long you're going to keep this data is another thing, right? The availability of this data is so some of this data you might want to put some uh, duration to it, right? So this data will be exposed for available for usage for 1 year. After that, you might deem the data to be obsolete. Okay, so these are some guidelines. Okay, when you talk about data being the life cycle and knowing what are the sensitivity in managing this data. Right, then we move on to data source. Okay, so data source simply means where is this data going to come from, right? The source of this data. So the source of this data could come from all these places, like from database, okay, whether it can be a flat file, okay, or it can be from any multimedia, and it can be from any relational database or transactional record, or it could be from some audio, okay, or some video recorder, etc. So there will be some of these database that you could have actually retrieved from. Then another data source will come from data warehouse, right? There are basically repository of collections of multiple source of data, right? So it could be a central repository where it has lots of this data coming from various data storage devices, right? Or the cloud, right? The cloud that you could be retrieving from, right? So there are also a lot of those mini data mart, okay, that is inside the data warehouse that you can also retrieve from, right? So these could be data from the various departments, okay, the marketing department, the sales department, the engineering departments. So there could be some of these data, like for example the personal profile, the manpower profiles informations, right? Another big source of data, okay, where you can source is actually the internet, right? So internet itself contain a lot of data, and these data are like free, right? Some data source you need to pay in order to retrieve, like for example news journal, right? So if you want to know more about certain data about some news or historical background, sometimes you need to pay some journal, okay, news 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 agency for to be able to get some of this data, right? So some data you need to pay, but at least from the internet, a lot of free data is actually available, right? And that is one of the very big source of data, right? And like for example, you want to find out the population in different region, right? So you can easily surf the internet to find some of this data, right? So in Singapore, we have the data.gov.sg, right? So that is the website where the government actually put in lots of data in, right, where you can retrieve. Actually, they are all free. Like for example, how many males and females in Singapore, what is the age group, what is their educational profiles, and where are all the primary schools, uh, or the good primary schools residing in which region, right? So that's government, right? They try to make some of this data, if not available. So you can see over here, right? The data.gov.sg. Well, you can go there and take a look, right? There are plenty of free data made available by the government, right? Especially like even like properties pricing, right? So you can also go to any other website to find out more about uh like for example, you can go TripAdvisor, right? TripAdvisor, there you can find a lot of those Airbnb hotel or which hotel in certain areas of interest that you're going, right? Okay, the next data source could be coming from regular data streams, right? Streaming from devices. Okay, that's where we talk about IoT devices, sensor monitoring, right? Like even like if you are monitoring the network traffic, so you'll be basically relying on some of this network traffic data coming from the routers, from the switches, from the hubs, right? So they could be streaming you with lots of data for you to analyze to see if there's any abnormalities in the network traffics. Okay, anybody trying to gain access at irregular hours, etc. So these are data coming from electronic devices. Okay, we also mentioned about healthcare, right? Health got lots of data that the nurses, the doctor will be monitoring, right? So these are data streams, right, of data coming in. And of course, there are other information repository from various portal of other means like even the central libraries, right? Or Central National Archiving Agency where you can also retrieve some of this data, right? Whether it's electronic or non-electronic data. Okay, so you might also need to transform some of those non-electronic data to electronic form before you can analyze. For example, newspaper, the olden days newspaper. So you might need to scan some of these old newspaper articles and make them electronically, right? So that you can index them, you make it searchable easily. Right, we move on to the next thing about the data, right? We talked about this before. The data can be structured data. What is structured data? Structured data is something that is identifiable and you can organize in certain structure, right? You can like for example put them in columns, you can put them in rows, records, etc. So when you put them in a structured manner, it's easier for human to basically look at it or search it or index it or even to sort it in various order, right? So and usually this data format they is comes with predefined data types as well as the as length. Okay, right? Example name, right? Name has a 30 character long, right? So you can define the length, right? And it's maybe alpha text alphabet, right? It's in a matter of strings, right? So you can define some of these data type, right? Some of them, of course, are just pure numbers, like for example, pin number, right? So you define that and six digit or 8 digit, etc. So so usually data that can store in the database are usually structured. So so you have another data that is unstructured, right? So when you have something that is structured, you might have something that is unstructured. So what are unstructured data, right? So unstructured data are something that, of course, you can't define them in any specific data types, right? So it doesn't fit well into any of those relational database, right? So example, picture, right? Big Mac objects, right? Images, audio file, videos. These are something that you can't store them properly in any of the database, right? So you might need to convert it to some binaries, right, before you can actually properly address them, right? So there are also some unstructured data like one whole paragraph of uh, of text, emails, and embedded stuff, right? So it comes in various form of objects, right? Like your email, right? Your email have a email bodies, but it comes with attachment. It comes with pictures in there, so it's a mixture of those. So it's what we call it's like a form of objects, right? Where it has embedded different uh, block of objects in there, right? So that is unstructured, make it very difficult to store in the database. Huh? Oops. Right, data source. Um, Right, let's take a look at the data. So after looking at the data that have a structure and non-structure, then some of these raw data are really, if you look at the raw data, means it has not been processed, right? So sometimes before you can look at the find the data meaningful, you need to process this raw data, right? Before you can actually mine it or even have a way to analyze it, right? So you need to refine this data, right? So what do you mean by this? We need to do some pre-processing, right? Example, data that is incomplete, right? So when you do market survey, some data are really incomplete, right? Some never fill in the full name, some fill in other names, some put blanks. Okay, so have missing value. So that we have to deal with this, right? So when you have a case where the data is not complete or blank, what you gonna do with it? Right? So that's where you have to come in to do some pre-processing, right? So maybe all the noun value you replace by NA not applicable, etc. Right? So there are some data that is noisy, which means that they got error. Okay, they are corrupted. We can't use it. Like example, uh, if we are looking at data that is temperature data, right, we'll expect it to fall within 30 to 40, but somebody give 100, then those are really out of range. Those are data that is having error, right? So cannot. So then we also have data that is inconsistent, which means it doesn't follow certain format, right? Like female, male. Some put F, some put M. So you have different format. So you might want to transform all these format into the same, okay, unify them. And then some data have duplicate, which means that somehow it's duplicated, right? Like example, emails. Some of us have more than one email, right? But we submit a few times, so actually it's all the same person, right? So there are some duplicates, or sometimes two of us work on the same data. We have two copies, and when they merge, right, then we have duplicated rows also. So data preparation, this is some survey done by some Ford, right? So Ford, they actually do this survey, then they actually check with the data scientists during their data preparation, what is the most time that they spend on, right? So a lot of them says that uh, they spend 60% of their time not actually to analyze the data, but actually to organize and to clean the data, right? So you can see that cleaning data, organizing the data, ensuring the data collected are correct. It's not it take a long time, right? And it's a very hard job, right? Especially when you have data that is like thousands of records, hundreds and thousands of records, or millions of records, right? You really need some tools to basically help you to clean some of this data. Okay. And of course, what is the least enjoyable part in the data scientist, right? So if you are aspire to become a data scientist, you'll be put off by some of these things, right? So in fact, a lot of data scientists regard that organizing in fact, that's what you see. 60% of the time, they don't really like to do their job because it's all about cleaning the data and organizing the data. It's not so much of trying to understand or mine the data, right? So you realize that a big part of your job is actually not to do the. If you find that you are very keen in analyzing data, well, think about it, right? You only spend like 30-40% of time doing those, right? Other than that, a lot of time is basically uh, uh, doing the undesirable or least enjoyable part of the work, right? So, so So we mentioned about data cleaning. So very quickly, data cleaning is like clean, wash the data, clean the data. So any dirty part is fall off. You delete all those data that is not right, incorrect, inaccurate, irrelevant, right? So again, internet got lots of data, but a lot of data could be expired, outdated. So you need to clean those data, right? So just like washing your hand, dirty hand under the water, right? So you need to do that. After that, you need to, once you clean the data are sampled correctly, you need to combine the data, and that is also another challenge, right? How do you combine so much data, put them in, consolidate them together, right? So joining the various tables, data source, into one tables, right? So we have tools to help you to do that. And then you also need to transform this data. After you integrate already, you need to convert this data into a format that you want, or format that another app would be able to receive, right? Example, like maybe you collect those data is in the month, day format, but you need to convert them into maybe day, month, right? So you need to convert, right, to the right order, right format, right, before it can be used, right, by another program or by another system. So that's where we talk about extract, transform, and load. That's what is a ETL means, right? To be able to extract from the various different system, like from the ERP, right? From the customer relationship management, from the various other data source and files, flat file, relational database. You go to find ways to extract them. After you extract, you go to transform them into the right format, right? And then load it into your modeling machines or process before you can process, right? Or you can load it into a data warehouse before you start to generate some report or do some ad hoc analysis, right? So you might also want to arrange them into different data mart, right? So here is a table that talk about the differences between data warehouse and data mart, right? So data mart essentially is just a smaller scale of the data warehouse, right? So data warehouse is like the enterprise, okay? The enterprise data or huge amount of data. So a subset of it is actually the data mart, which is a smaller scale, right? So it could include a more specialized group of data. So instead, like you can have a corporate data in a data warehouse. Then under the corporate, you can have data for the sales department, data compiled by the engineering department, the accounting departments, and various. So there are more of the less more specialized group of data, right? That you want to categorize them properly. So that's all under data mart. Okay, so what's the purpose of having this extract, transform, load, right? So basically, we want to only to acquire only certain subset, because sometimes you wouldn't want to have all the data, right? You just want to scrutinize certain part of data, and that is relevant. Then of course, the you have to convert some of this database is to another form, right? So we can also be talking about migrating the data from one database to another platform, right? Or another database. Example, from MySQL database, you want to convert it to Oracle database, right? Or you want to convert from a relational database to a flat database, or you want to convert from a production database or staging database to a, a live database, right? Okay, maybe we pause for a moment. My wife want to go. Yeah, that's my lovely wife. Okay, commercial break. Right. Well, anyway, we are finishing. So extract. So here we are trying to extract data. All right. This is about extract. Extract simply means to read and retrieve the required data from the various data sources. Right. So then of course we talk about this. To why do we need to clean the data? Okay, so to ensure quality of the data, right? If you don't clean the data, then garbage in, garbage out, right? So that's why we need to clean the data. Then what do you have? What do you do inside the to clean the data? There's lots of things that you need to clean, right? So basic data unification rules. So we mentioned this. You want to basically standardize the data, right? So like example, we mentioned this male. Some people put, when you do survey, some people put male, they are man, they are M, right? So you want to standardize all this data into one form. Either man means or M, or woman or female or F, right? So you want to standardize so that at least you can do some calculations, right? Or some null value, you want to convert them into not applicable, not provided, etc., or nil, etc., right? Or you want to convert all the phone number, some give the country code number, right? So you want to standardize the format also. So there are various means. Anyway, we'll be going through some of these ways of cleaning the data, and you might want to merge the data as well. Then of course, transforming the data, you need some rules. You need to apply some rules, right, to it. So some data you can just take it as it is with the same data type, same dimensions, but some data you might need to generate. Like for example, you want to generate the total cost, you want to generate the areas. For example, you collected the length, you can collected the breadth, right? So you want to calculate the area. So some data are newly added, you want to derive the values, right? You want to put in. So that's where the transformation comes in, right? Based on the formulas that you want to put in place. Then after you've done all this, okay, extract, transform, all very nicely done up, then you want to write some of this resulting data that you've done, and then save it into a data warehouse or certain database. Okay, so that's the loading part, right, before you start doing things. So managing of so there are expectations when you go through the EL ETL, right? So be prepared that sometimes when you do all these processes, they might fail. Okay, there are many reasons why fail, right? So some could be there are some processes that are wrong, some formula you put is wrong, the extractions is not clean enough, right? There are some other consideration that you have not been thought of, right? So you might want to ensure that you might want to do multiple time, multiple check, and then don't think that one time job, okay, will be very successful, right? So you might be prepared to do some staging, right? So might not want to straight away load your whole data, resultant data into the production data, for example, right? So you might want to store some of this intermediate data results from this all this ETL process in a staging warehouse or staging uh, server first. Okay, right. So there are a lot of these data ETL tools available. Right, so there are Oracle Data Integrator, the SAP, the SQL Server Integration Services. So these are all enterprise level. Uh, I think we will not be using at least for this module, right? But in this module, we'll basically be using the more simpler task, which is actually the Excel, okay, Microsoft Excel, right? So incidentally, you will find that Microsoft Excel will be the one that will be your practical test later on, okay? So we'll be using Excel, Microsoft Excel. You'll be learning how to use Microsoft Excel to clean the data, to merge the data, okay, to delete trash some of this data right, in the area to prepare the data for analysis. Right? So good. Finally, with that, I want to end this chapter. Right? So Right. So thank you very much for your attention. We'll see you again in the next chapter. Oh, where's my okay. Okay, so signing out. Thank you.